let's look at a specific type of factoring that's really kind of fun and easy. So let's start with multiplying this binomial and see what happens. So you will notice that these are identical except one has a plus and one has a minus. So when we multiply these, do the box if you want to, you're going to get x squared plus 8x minus 8x minus 64. So if you want to fill in your little box, you can see that the like terms, when combined, actually cancel each other out and go away. So what is your answer? X squared minus 64. This is called difference of two squares. Here's a perfect square. Here's a perfect square. In the square root of 64, 8. And this is difference, subtract. So when you multiply these two, the middle term cancels and you get this x squared and 8 squared with a minus in between. So wouldn't it be easy to go backwards and factor these? So when I'm factoring these, I don't have to make my box, I don't have to list my factors, I don't have to think about anything. I just know that if this is a perfect square, this is a perfect square, and there's a minus in between, then I know that it's difference of two squares. That means I do the square root of x, I do a plus and a minus, and I do the square root of 36. It's that easy. So difference of two squares, or dots as I like to call them, are the easiest ones to factor, and we need to be able to recognize them quickly. So is this a perfect square? Yes. Is this a perfect square? Yes. Is that a minus? Yes. So we can factor it. Square root of x squared is x. Square root of 16 is 4. 1 plus, 1 minus, and we're done. Now look at this one. This is a perfect square, and this is a perfect square, but that's not a minus. That's not the difference. That's the plus. This cannot be factored. So you would either write prime, because remember, a prime number is something that the only factors are itself and 1, so it can't be factored, or you could just write not factorable. But this is not a difference, so this is not difference of two squares. Let's look at this example. 4x squared. Is that a perfect square? Yes. The square root of 4 is 2. 25 is a perfect square. This is a minus. So we're going to go 2x, square root of 4 is 2, square root of x squared is x, 2x plus minus square root of 25 is 5, and we're done. One thing I didn't mention is when you're factoring, you always look for a GCF first. Is there a greatest common factor? Well, no, there's not. 4 and 25 don't have a common factor. But look at this one. Do 18 and 8 have a common factor? Yes, they do. They can both be divided by 2. So the first thing we do is take the greatest common factor out. We divide by 2. So 18 divided by 2 is 9. 8 divided by 2 is 4. Now that I've factored out the GCF, the greatest common factor, now is what's left difference of two squares. Yes, there's a minus for the difference. This is a perfect square. This is a perfect square. You have to leave the 2. That GCF stays as part of your answer. It can't go away. Square root of 9 is 3, so we have 3x and 3x, a plus and a minus. Square root of 4 is 2. Now we're done, but please don't make the 2 go away. The GCF has to stay as part of your answer. All right, 2 more examples. So 100x squared minus 1. Is 100 a perfect square? Yes. X squared is a perfect square. At first glance, you might think 1 is not a perfect square, but it is. The square root of 1 is 1. 1 times 1 is 1. So, square root of 100x squared is 10x. 1 plus, 1 minus, square root of 1 is 1. So that one was a difference of two squares, and it can be factored like that. If you're ever not sure, just make your box and check. Check your answer and see if it indeed is a difference of two squares, if you end up with what you started with. Okay, here's this part's right. Let's see if these terms cancel. Minus 10x plus 10x. Yes, they cancel, so I did it right. Let's check the next one for a GCF, because we should always, always, always do that first. Since I wrote these, I know which ones have a GCF, so I haven't been always, always, always checking first, but you should. Oh, look, they're both divisible by 5. 5, and you could use your calculator to check and see if they had a bigger common factor. 5 goes into 125, 25 times. 5 goes into 45, 9 times. Okay, I took out the GCF. Now, is this a perfect square? Yes. Is this a perfect square? Yes. Did you notice that before I took the 5 out, they were not perfect squares? Leave the 5 and factor your dots. 25x squared, the square root is 5x. 1 plus, 1 minus, square root of 9 is 3. This is my answer, including the GCF, because if I multiply back through, I have to get what I started with, or I haven't factored it right. So that's difference of two squares.